Hello, in this video, we are going to take the idea of the nth term Taylor polynomial to use this to approximate. So in the last video, we found that we can approximate any function by using these nth term Taylor polynomials, which are polynomials where the coefficients are the terms c sub n equals the nth derivative at our center A divided by n factorial. So we walked through the process of finding this. And so we're going to use this on this example of finding the third degree. So p sub 3 of x, Taylor polynomial at a equals 4 for f of x equaling the square root of x. So the third degree Taylor polynomial is this polynomial going up to the third term. The third term isn't written here, but it will be f of a over 0 factorial x minus a to the 0, which remember 0 factorial is 1 and x minus a to the 0 is also 1. Plus f prime of a over 1 factorial. 1 factorial is 1. X minus a to the first, plus the second derivative at a over 2 factorial, x minus a squared, plus the third derivative at a over 3 factorial, x minus a cubed. And then we would stop. We don't need to find any more terms. A is 4. So when we find this, we're going to plug in 4 to everything. But we need to find these derivatives. So off on the side, I'm going to say I want to find these derivatives for the original function would be 0, the first derivative, second derivative, and third derivative. So fn of x and fn at 4 because a equals 4. So our function is the square root of x. The other way to write that would be x to the 1/2. So the first derivative is 1/2 x to the negative 1/2. The second derivative is negative 1/4 x to the negative 3/2. And the third derivative is 3/8 x to the negative 5/2. Just using the power rule on each of those. Now, when I plug in 4, the square root of 4 is 2. When I plug in 4 to the first derivative, I'll have 1/2 times 1 over 2, as we have that negative exponent, sending the square root of 4 to a denominator. So 1/2 times 1/2 is 1/4. The second derivative is going to be negative 1/4 times 1 over 2 cubed. I'm just turning all of these 4s into 2 because they're always having the square root taken. So this is negative 1/4 times 1/8, or negative 1 over 32. And then the last one will be 3/8 times 1 over 2 to the 5th, or 3/8 times 1 over 32, which is 3 over 256. So there are the derivatives that we're going to plug in to our approximating Taylor polynomial. So plugging these in, f of a is 2 over 0 factorial is 1, as has been stated. X minus a to the 0 is also 1. 1, 1. Plus f prime of a is 1/4. 1 factorial is 1. And then x minus 4, a is 4. Plus our second derivative, which is -1/32, times x minus a is 4, squared over 2 factorial, plus our third derivative, 3/256, times x minus a cubed, and a is 4/3 factorial. Now, when we need to find these Taylor polynomials on assessments where calculator isn't given, this is plenty simplified, but I have also been able to find the more simplified version working these factorials in, which is 2 plus 1/4 x minus 4 minus 1/64 x minus 4 squared plus 1/512 x minus 4 cubed. Again, this row is more than simplified enough, but we can simplify them further should we want to. So p sub 3 of x is approximately the square root of x function. It will vary from the square root of x. One, since this is a polynomial, I can plug negative numbers into a polynomial. I can't plug negative numbers into the square root of x. So there's one way this is an approximation. The second is the farther I get away from 4, like if I was all the way out at 100, the polynomial and the square root of x could be very different from each other. However, really close to 4, these are going to be about the same. So if I want to approximate the square root of 4.02, that would be approximately this Taylor polynomial at 4.02. So I'm going to plug 4.2 in to this Taylor polynomial. So we'll have 2 plus 1/4, 4.02 minus 4, minus 1/64, 4.02 minus 4 squared, plus 1/512, 4.02 minus 4 cubed. Now, simplifying this down, there are some decimals I don't particularly want to deal with without a calculator, but do know that 4.02 minus 4 is just 0.02. So I can at least simplify that down. So 0.02 minus 1/64, 0.02 squared, plus 1/512, 0.02 cubed. This here is approximately the square root of 4.02. With a calculator, I actually worked this out on the side. Again, on an assessment without a calculator, when asked to approximate, this would be simplified enough to understand this number would be approximately the square root of 4.02. However, with a calculator, we have that I found this right-hand side number works out to be 2.00499376558. And the square root of 4.02 is 2.004993765 8. I just took a pause. I wrote my numbers down wrong. This one ends in 6, 3. So the polynomial approximation is 2.00499376563. And the square root of 4.02 is the 2.00499376558. However, they are the same for 9 decimal places. 1, 2, 3, 4, 5, 6. Yes, for 9 decimal places. So those are very similar. It's a very good approximation. And so these polynomials create some very good approximations, which in the next video, we'll talk about how can we tell how good of an approximation it is.